Hello students, in this video we'll be learning about the different types of quadrilaterals. First let's list them down, the ones that we have mentioned in the previous video. The first one we came across was the trapezium. The second one was parallelogram. The third one was rectangle. Fourth was square. Then it was the rhombus, and finally we had the kite. So now in this video we'll be going through each and every one. Now for the parallelogram we will be doing in details in subsequent videos, because there are a number of theorems that we need to go through in parallelogram and a number of properties that we need to discuss of parallelogram. But in this video we'll briefly list down certain main properties of parallelogram without going into the depth of it, just like how we will be going through briefly through the properties of trapezium, rectangle, square, rhombus and kite. So first let us begin with the first one, that is trapezium. So what are the main properties of a trapezium? First we'll draw a figure of trapezium, and that will help us to understand what are the various properties of a trapezium. Okay, and I list them down as A, B, C and D. Now we had said that one pair of opposite sides are parallel to each other. So in this we can say side AB is parallel to side DC. Okay, so side AB is parallel to side DC. Now AB over here is and DC, these are referred to as the bases of the trapezium, and these non-parallel sides, these are called as the legs of the trapezium. See, they look like legs. Okay, they are known as the legs of the trapezium. In case, this is the first point. Okay, second point is that diagonals of a trapezium intersect each other. Okay, the diagonals of a trapezium intersect. So you can say AC and BD intersect. AC and BD are diagonals, you can say, are diagonals, and they intersect each other. Okay, this is another property. And let's say we draw another line. Okay, we get rid of this diagonals so it won't be like a distraction. Okay, and we draw a line connecting the two non-parallel legs of a trapezium. Then this line has got to be parallel to the parallel sides. Okay, so we list them down over here. If we draw a line from one non-parallel side to the other non-parallel side, then this line will be parallel to the two, you can say, AB and DC, which means the other two parallel sides. There is another property of trapezium, that is the adjacent angles. That is, if you take adjacent angles, so you will have angle A plus angle B, the sum of them will always be equal to 180 degree. Similarly, A and D will always be equal to 180 degrees, and angle B plus angle C will be equal to 180 degrees. So also angle C plus angle D will be equal to 180 degrees, which means, in other words, that adjacent angles in a trapezium are supplementary. So we write over here, adjacent angles in a trapezium are supplementary, okay, which means it is 180 degrees. So these are the properties of a trapezium. Coming next to the parallelogram, okay, so we have noted it down that in a parallelogram opposite sides are parallel, as the name suggests over here. Now we'll list down the various properties. Many of the properties will be discussed in subsequent videos where we discuss the theorems with respect to parallelogram. Here we just list down basic properties of parallelogram. Number one, let's begin with parallel, because the name says parallelogram. Opposite pair sides are parallel to each other, which means AB is parallel to DC, and we have AD parallel to DC, okay, so which means opposite sides or pair of opposite sides, you can say pair of opposite sides are parallel to each other. Next property, the sides which are parallel are also equal to each other, which means AB is equal to DC and AD will be equal to BC. So we can say AB equal to DC and AD is equal to BC. In other words, pair of opposite sides are equal to each other. Done. Now, in a parallelogram, opposite angles are also equal, this way. So we can say that angle A is equal to angle C and angle B is equal to angle D. Opposite angles are equal. What else can we see over here? If the diagonals AC and BD, they bisect each other, okay, they bisect each other. So that, in other words, if we put a point over there in the center where they bisect, let's say this is O, then we can say, put it over here, that AO equal to OC, this one equal to OC, and BO equal to DO or OD, same thing, means diagonals bisect each other to equal parts. This is another property of a parallelogram. There is another fact that angle A plus angle D will be equal to 180 degrees and angle B plus angle C will be equal to 180 degrees. Why? See, these are two parallel lines, right? And then this line and this line, these two lines which are parallel to each other, but if you have a look from just these two sides, AB and DC, these two are actually transversals. And if these two are transversals, we know a property where the transversal intersects two parallel lines, that internal angles on the same side of the transversal, they are supplementary, and hence you can say that angle A plus angle D is equal to 180 degrees and angle B plus angle C is equal to 1. So this is basically internal angles, okay, are supplementary. means 180 degrees. So these are some of the main properties of a parallelogram. Most of the quadrilaterals that we encounter are usually parallelograms, most of them. Okay, we'll move to the next one. Next we have something called as a rectangle, and we have noted down the main point of rectangle is that all angles of a rectangle are 90 degrees. That means all angles are also equal. That means put over here angle A equal to angle B equal to angle C equal to angle D. All of them are equal to 90 degrees. So we note down over here all angles are right angles, hence equal to each other. Okay, that is one property of a rectangle. Another property of a rectangle, if you notice, is AB is parallel to DC and AD is parallel to BC, just like a parallelogram. It's a type of a parallelogram. You have AB parallel to DC and we have AD parallel to BC. There's another thing that AB will be equal to DC and AD will be equal to BC. These properties, these two, are similar to a parallelogram. So you know a rectangle is a type of a parallelogram wherein the opposite sides are parallel and the opposite sides are also equal. So we put over here that opposite sides are parallel and opposite sides are equal in length. And similar to the parallelogram, its diagonals bisect each other. So it will be this way. Put an O over here, then we have AO equal to CO and BO equal to DO. So diagonals bisect each other. So the question now arises is the relationship between a rectangle and that of a of a parallelogram. All rectangles, can they be parallelograms? Yes, they can be parallelograms, but all parallelograms need not be rectangles. See, because this is a parallelogram, it has almost all the properties of a parallelogram. Opposite sides are equal and parallel, diagonals bisect each other. Now the only point of difference here is that all angles are equal, but in a parallelogram, like if I draw a parallelogram over here, okay, this is a parallelogram. If we know that opposite angles are equal, okay, in parallelogram all the angles are not equal, opposite angles, then how can we say that all types of rectangles can be parallel? Now see, if one of the angles of a parallelogram turn out to be 90 degrees, then all have to be 90 degrees. Why? Because have a look, we have said opposite angles are equal. If this is 90 degrees, this one has also got to be 90 degrees, correct? Okay, now these two angles are equal, these are 90 degrees, these are 90 degrees, total is 360 degrees. That means now the two are left, total should be 180 degrees, but that doesn't mean that they have to be 90 degrees each. But there's another property that we discussed in the previous figure, that is in the parallelogram, that since they are parallel to each other and this is a transversal, that means the sum of this angle and this angle, this plus this one plus this one, should be 180 degrees because they are interior angles and interior angles are supplementary. And if this angle is 90 degrees, then the other angle has got to be 90 degrees. And if this is 90 degrees, then the angle opposite to that has also got to be 90 degrees. That means all are 90 degrees, and that makes it what? A rectangle. Okay, but remember, all parallelograms are not rectangles. Okay, because we have parallelograms with different angles. Okay, some will be acute, some will be obtuse. So the bottom line is this: all rectangles can be or may be. Doesn't mean that all rectangles are parallelogram, or rectangles may be parallelogram, but a parallelogram need not be a rectangle. Okay, I hope you have understood this concept. Let's move to the next one. Coming to the square, we have discussed that in a square all sides and angles are equal, which means AB is equal to BC equal to CD equal to DA, and angle A is equal to angle B is equal to angle C and angle D. We will list that down first. AB equal to BC equal to CD equal to DA. All sides are equal, and angle A equal to angle B equal to angle C equal to angle D. All angles are equal. Also, opposite sides are parallel to each other, which means AB is parallel to DC and AD is parallel to BC. AD is parallel to BC. Okay, so opposite sides are parallel. Next, we have said all these are equal, but all angles are also 90 degrees. Since they are all equal to each other, they have to be 90 degrees. That means angle A equal to angle B equal to angle C equal to angle D equal to 90 degrees. All angles are right angles. And what can we say about their diagonals? Obviously their diagonals have got to bisect each other. Okay, so we can say that as well of the diagonals of a square. But the important point to be noted in case of these diagonals is that the diagonals of a square bisect each other at 90 degrees or at right angles. Okay, so I'll list them down over here. That it's true that they bisect each other. That means there are two things. First of all, if we list this, put a point over here, that AO equal to CO and BO is equal to DO. So that diagonals bisect each other, but they bisect each other at right angles, which means that AC is perpendicular to BD. AC perpendicular to BD. Okay, this is another point. Diagonals bisect at right angles. Fine. So in other words, it says AO is perpendicular to BD, or you can say BO is perpendicular to AC, whichever way you see. I've taken the whole thing, AC perpendicular to BD, which means they are obviously perpendicular to each other. That is, it is 90 degrees at the center. Okay, this is another property of square. So comparing wise, if you compare this to a parallelogram, a square is also a type of a parallelogram because opposite sides are parallel and equal. Then the opposite sides are equal to each other. These are properties of a parallelogram. Once again, we can say that a square can be a parallelogram. Okay, a square can be a parallelogram, but a parallelogram need not be a square. Or in other words, we can also say this is also a type of a rectangle, because you see opposite sides are parallel and equal. Then we have right angles Okay, all angles are right angles, so they are, as I said at the start, they will have overlapping properties. You have to look for what distinguishes a square from a rectangle and a parallelogram, or what distinguishes a rectangle from a square and other of its cousins, you can say, okay, or siblings. We need to look out at certain things that distinguish, like for example this thing, you see that they bisect each other, the diagonals bisect each other at right angles. Okay, let's move to the next point. Next we come to a rhombus. In a rhombus we have discussed that all sides are equal. So we list that down. All sides are equal. AB is equal to BC, equal to CD, equal to DA. All sides are equal. What are the other properties that we know of a rhombus? In case of a rhombus, the opposite sides of a rhombus are parallel to each other. That means AD is parallel to BC, and we have AD is parallel to BC, and we have AB parallel to DC. So opposite sides are parallel. This is another feature of a rhombus. The next we know about a rhombus is that opposite angles of a rhombus are equal, which means A will be equal to C and D will be equal to B. Right over here, angle A will be equal to angle C and angle D will be equal to angle B. Opposite angles are equal. The next property or feature of a rhombus is that the diagonals of a rhombus bisect each other at right angles. First of all, they bisect each other. I will put this as O, which means that AO is equal to CO and BO is equal to DO, and also the fact that AC is perpendicular to BD. Okay, so we can say diagonals bisect each other at right angles. These are two other features of a rhombus. What else do we know? We can say that the sum of two adjacent angles of a rhombus are supplementary or equal, can say equal to 180 degrees. So put it down over here, which means that angle A plus angle B will be equal to 180 degrees, or angle B plus angle C equal to 180 degrees, or angle C plus angle D equal to 180 degrees, or angle D plus angle A equal to 180 degrees. In other words, adjacent angles are 180 degrees or supplementary. That is another feature of a rhombus. Next we will go to the last type of quadrilateral, that is the kite. Okay, in case of a kite, we have discussed that the two pairs of adjacent sides are equal, which means that AD will be equal to AB and DC will be equal to BC over here. Okay, so we make a note of that. AD equal to AB and DC equal to BC. So you can say pair of adjacent sides are equal. Okay, so these are two adjacent sides, and only this pair, the sides are equal to each other. Similarly, over here we have two adjacent sides which are equal to each other. The other feature that we know of a kite, similar to that of a rhombus, is that the diagonal bisect each other at right angle. So if you draw a diagonal like this, sorry, excuse my diagram. So we can say over here that AO equal to CO and DO equal to BO, and also the fact that AC perpendicular to BD. So diagonals bisect each other at right angles. Okay, so if the sides of a kite become equal to each other, then it will get converted into a rhombus. Otherwise it is like how a kite looks, that is only the above two sides are equal to each other and the below two sides are equal to each other, whereas the diagonals bisect each other at right angles. Okay, so these are the six main types of quadrilaterals that we have learned. We need to keep in mind that properties will overlap each other, and there are actually many more features or properties of these six quadrilaterals that we have learned that we have not covered in this video because it is not required for class 9. Okay, for whatever was required as per your syllabus, as per your portion, has been covered in this video. So if you have liked this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive notification whenever a new video is posted. So thanks for watching. See you in the next video.